Hi, this is Dr. John Bergdorf. In this video, we're going to explore what is meant by the ideas of increasing, decreasing, and constant as they relate to functions. And the definitions will seem a little complicated at first, but they're intuitively pretty clear, and you'll see very clearly towards the end how these ideas could be very relevant in applications. So before I can define anything else, I have to define the phrase open interval, which you'll see in other definitions. So an open interval is simply an interval that does not include its endpoints. So if you think about interval notation we've explored so far, if you have an interval like this one that does not include either endpoint, that would be considered open. If you have an interval that does include the endpoints, that's not considered open. In fact, that is very cleverly called closed. Now, what about infinity? Because infinity is not really an endpoint, because it's just the concept of going on forever and ever, an interval that does not include the endpoint on one side but goes to infinity on the other, that would be considered open as well. So that's open, and this is open. None of those are including endpoints. And you might say, well, what about an interval that was included one endpoint but not the other? Well, that's not open either. In fact, that is very cleverly called half open, although that's not a phrase that we need to worry about. We're going to focus our attention on open intervals like these. All right, now with that background, we can go ahead and get started. Let's talk about first what is meant by an increasing function. A function is said to be increasing on an open interval, increasing on an open interval, we're going to call that open interval I, if whenever x1 and x2 are chosen from I, the interval, so that x1 is less than x2, it turns out that f of x1 is less than f of x2. Now that may seem like quite a mouthful, so let's just take a look at what that means. Suppose you've got the standard xy plane, and I'm not going to actually mark this off, I just want it to be general, but let's say that my open interval runs from, say, here to here. That's my interval I. Now, what the definition says is this. If whenever I pick x1 and x2 from the interval on, this is an interval on the x-axis. So let's say I pick my x1 to be here and my x2 to be here. Whenever I pick my x1 and x2 out of that interval so that the x1 is the one on the left, the lesser one, if the function is increasing, that means f of x1 would be less than f of x2. How might that happen? That might happen something like this. Maybe my f of x1 is here. And remember, the idea is f of x1 is the value of y when x is x1. So my graph would have to be doing something like this, where one of the points on the graph would be right there. And x2, f of x2 would have to be greater than that. So I would have to have that point be, say, maybe up here somewhere. So the point on the graph would be right there. If this is true for all choices of x1 and x2 throughout that interval, then we say that the graph is increasing. Now this has to be wherever you pick x1 and x2. So let me kind of show a different picture. I'm going to basically draw a similar graph, but just show you that no matter where you pick x1 and x2, as long as x1's on the left, f of x1 has to be smaller. So let's say my interval goes from here to here. This is my open interval, and again my graph, maybe looks something like that. And it doesn't matter where I pick my x1 and my x2. Any time I pick x1 and x2 in that interval I, is it true that f of x1 is less than f of x2? And that would be true if I put them right here. If I chose them over here, like maybe x1 and x2 are way up here over near this edge, is it still the case that f of x1 is less than f of x2? It's close, isn't it? But f of x1 is still less than f of x2. How can we say that more intuitively? Well, I believe what that's saying is that as your points move farther and farther to the right, the y values have, on the x-axis, as your values move farther and farther to the right on the x-axis, the corresponding y values have to be moving upwards. So from the left to the right, the values of y are going up. Let me look at something, just another case here, just to emphasize exactly what I'm talking about. I'm going to draw a graph here where, again, I'm picking an interval. This is my interval I, and I'm going to draw my function, and I'm going to draw it like this. Okay, so x1 and x2, if I were to pick them over here, and see I'm picking x1 to the left of x2, it's still the case that f of x1 is less than f of x2. But see, this has got to happen no matter where I pick x1 and x2 in my interval. Look at what happens if I were to pick x1 and x2 over here. Again, x1 on the left and x1 on the right. See how things reverse? Now f of x1 is up here, and f of x2 is actually lower. It's kind of more like in there. And it has to be the case that no matter where you pick x1 and x2, with the x1 to the left of x2, the f of x1 must be less than f of x2. So the values of y have to be continuing to move up as you move from left to right. If they start moving down, it's no longer increasing. Hope that makes sense. That actually will lead us directly into what we mean by a decreasing function. A function is said to be decreasing on an open interval if whenever x1 and x2 are chosen from the interval with x1 on the left of x2, it turns out that f of x1 is greater than f of x2. So what does that look like? Well, let's draw another graph. And let's say this one looks something like, let's pick my interval again. This is my interval I. And the graph is doing something like that. Now, here, when you pick x1 and x2, and you pick x1 to the left of x2, notice that f of x1 is greater than f of x2. So the idea is as you move along the x-axis, as you choose points farther and farther to right on the x-axis, the values of f of x1 are going down. So that's what's meant by decreasing. Now, a graph can be increasing, and we've kind of seen what that looks like. Again, as you move from left to right, the values of f of x are going up. Or it can be decreasing. As you move from left to right, the values of f of x are going down. Is there any other option? Yes, there's one more, and that's called a constant function. A constant function is a function, or a function said to be constant on an open interval if whenever you pick x1 and x2 from the interval, with x1 on the left, the function values are the same. So what does that look like? So let's draw another graph, and let's pick another interval on the x-axis. Now here, what I want to happen is that no matter where I pick x1 and x2, with x1 to the left of x2, the function values are going to be the same. That means the y values are the same. There's really only one way that can happen. And the graph would have to, at least for that segment of time, be a horizontal line. Now, what can happen once you get outside of the interval that you're talking about? Well, then it might do other things. But on that interval I, we would say that this function is constant, meaning that the y values go neither up nor down. So, although those definitions seem pretty technical, I hope that helps make some sense. It may be nice to state those ideas in other words. See if this helps any or not. A function f is increasing on an open interval on the x-axis if whenever you read the graph f from left to right over the interval, so going from left to right, the values of y are going up. F is decreasing on an open interval on the x-axis if whenever you read the graph from left to right, the values of y are going down. And f is constant on an open interval on the x-axis if whenever you read the graph of f from left to right over that interval, the values of y are staying the same. Let's see if that makes sense with an example. So here I have a very strange looking graph, and I do want to interpret it a little bit so you know what I'm talking about. And what I'm going to end up implying is that this graph is increasing on some intervals, decreasing on others, constant on others. But perhaps I should explain what's going on first. So I'm going to mark it up and then erase that. See this little circle that's not filled in here? That implies that that specific point, which would be what, -1, -2, is not included in the graph. The idea there is that that graph goes right down to, but does not include that point. So that open circle implies a point that you get super close to, just infinitesimally close to, but you don't include. The solid dot up here refers to a point that is included. So the point 1, 2, 3, 4, 0.14 is a point on this graph, but the point 1, -2 is not. And similarly, this point is not included, but this point is. And that turns out to be a good thing, by the way, because if, for example, this point right here were included, I'm going to imagine coloring it in, I would then have 2 points right over one another with the same x-coordinate, and that would mean that it would not be a function. So we would rather that not happen. Let's clean this all up. Get rid of all the junk. Okay, starting over. So on which function intervals is the function f defined by the graph below increasing, decreasing, and constant? Let's talk about increasing first. So the open interval we refer to is always going to refer to an interval on the x-axis. And what you do is you imagine, as you read the graph from left to right, is there an interval where while you're passing through that interval, the y values are increasing, going up? Well, not back over here. Clearly, these y values over here are going down, and not through here because those y values are staying the same. However, beginning right here, if you're looking at the x-axis, and continuing on forever, as you read through this interval on the x-axis, we say that the graph is increasing. We see the y values going up. And you might say, well, hey, that point right there let's see, where is that? 1, 2, 3, 4, -4? That's included. So should I make that a square bracket instead of a round one? Well, we're going to kind of evade that issue altogether. You'll notice in the book that the questions are all in this form, on which open intervals is the function increasing. We could talk about intervals, or functions increasing or decreasing on non-open intervals too. But what I would simply report for the interval where this graph is increasing is I'd say it's increasing from 4 to infinity. Again, that's the interval on the x-axis where as you read the graph from left to right, the y values are going up. Hope that makes sense. Before I say anything, you think for just a second and tell me if you can see the interval on the x-axis, the open interval on the x-axis, where when you read from left to right, the values of y are going down. Take a second, think about where that is, pause the video if you need to, and then I'll tell you what I believe the answer is. Okay, let's give it a go. So we are again imagining that we are reading the graph from left to right along the x-axis on what interval or intervals are the values of y going down, and they seem to be going down basically through here up till we get to that point. And again, we report it as an open interval, whether the endpoints are included or not. So the interval on which the graph is decreasing would go from negative infinity up to negative 1. Increasing on the interval from 4 to infinity, decreasing from negative infinity to negative 1. And then finally constant, and I bet this is, I hope, getting slowly easier. As you look at this graph, again, reading it from left to right, is there an interval over which the values of y are staying the same? I think I'll do that in another color. Reading from left to right, between here and here on the x-axis, the y values are staying the same. And so it's going to be constant on the interval between negative 1 and positive 4. So, intuitively, not that hard. The formal definitions, again, are a little bit complicated, but they communicate a fairly simple idea. Now, we're going to see the idea of increasing and decreasing functions throughout much of the remainder of this semester. What I want to do is show you that these kinds of issues can show up in practical applications. Here, I have a graph. Now, it's not written kind of like mathematicians would want it written. I don't have a clearly delineated XY axis with a grid, but it basically does have an x-axis and a y-axis. And that's because people who aren't mathematicians aren't necessarily bound to follow our norms and rules. They can do whatever they want, but the concepts can still carry on. Let's see what this means. So the following diagram shows the high temperatures for International Falls, Minnesota during the first, that's grammatically incorrect, during the first 6 days in March. On what days was the temperature rising, falling? On what day did the maximum temperature occur? What was the maximum temperature? Let's focus on the rising and the falling. So these are more, colloquial terms, non-math terms, but they definitely convey the idea of increasing or decreasing. And reading the graph from left to right makes sense because that's moving forward in time. So reading the graph from left to right makes sense. And as I look at this graph, I recognize pretty quickly that from here to here on the x-axis, the y values are going up. So mathematically, I might say that this graph is rising on the interval from 1 to 3. Or putting it more in words, I might say that the temperatures are rising from March 1st to March 3rd. Are they rising anywhere else? Well, look a little bit later. Between the 4th and the 5th, went up again. So also on the interval from 4 to 5. So I can definitely talk about intervals where the graph is increasing on that date. How about falling? Well, the high temperatures are going, I'll change colors here. The high temperatures are falling between the 3rd and the 4th. Anywhere else? One more place, from the 5th to the 6th. And so the mathematical idea of increasing and decreasing clearly can be applied in a practical situation like this. Let me clear out some ink here and look at the final two questions. On what day did the maximum temperature occur, and what was the maximum temperature? Actually, what I mainly wanted to do with these two questions is point out that they're asking for something very similar, but not exactly the same. It's a different question to ask, on what day did the maximum temperature occur, than from asking, what was the maximum temperature? So on what day did the maximum temperature occur? Temperatures go up as you read up the axis, so we're looking for the highest temperature we can find, and what day did that occur on? I think the point we're interested in is right here. And to answer the first question, on what day did the maximum temperature occur, we would say the maximum temperature occurred on March the 3rd. That's when it occurred. The alternate question, though, is what was the maximum temperature? The maximum temperature would be the y value that goes with that particular x value. And the maximum temperature looks like it was a toasty 10 degrees. So the maximum temperature was 10 degrees Fahrenheit. Okay, I hope that helps both with the concept of increasing, decreasing, and constant, and also a little bit of a view of the fact that these are concepts that we actually will see and deal with in sort of everyday life. Take care.